Step 2 are the formula demonstrations. So I say here, show your work. And so for that, I need to see the formula written out and then the value of n plugged in and then worked out to the final result. We kind of know what the final result should be because all these OEIS sequences have right at the top the list of all the numbers. So this is double checking the OEIS basically. It's seeing whether the formulas that they have given give you the right answer. So there's not really any creative mathematical work here. There's no problem to solve. It's just showing at what exists out there in the world of combinatorics, the types of formulas that people have discovered over all the years, and how many different kinds there are. So it's just experience, gaining some experience in these formulas. The hardest part about it is probably the fact that the OEIS sometimes uses just pure text to type out the formula, and that means you have to translate a little bit occasionally. For instance, the word binomial there means it's using the combinations. So binomial 2 star n comma n is the same thing as 2n choose n. Luckily, a lot of times you can cut and paste that formula into Wolfram, and Wolfram will understand it because it knows what the OEIS means by its text formula. So in fact, that's what I did there, and I didn't have any trouble just having Wolfram spit out the exact answer or the exact typeset version of it. You might have to do a little bit of typing yourself, and you can use pen and pencil to write some of this in. Typing is the best, but if you write really neatly with your handwriting, put some boxes around each part, label the outline clearly, then I'll give full credit on the rubric for neatness there as well. So for in your email, I told you for each of the kinds of formulas that I said were worth working with for each individual, which values of n to plug in. So I assigned myself n equals 5 and n equals 6 on the first one. I plugged those in to that formula and got the two answers. And then there was a formula with a summation, k equals 0 to n minus 1. So in those formulas where there are k shows up, I saw several of those in people's formulas that I assigned values for. Those values of k are an index. So in this case, it went sum k equals 0 to n minus 1. And so filling that in, showing my work for n equals 3 means that I'll fill in k equals 0, then I'll fill in k equals 1, then I'll fill in k equals 2, and do that calculation. Now, this is a recursive formula because it has a's, a of k and a of n minus 1 minus k in the formula. Oh, and notice that in the OEIS, a lot of times instead of doing the subscript, they do it in parentheses. So I translated it into the subscript there. But when I typed it out, I went ahead and used the parenthesis. And then you are allowed, if you're using a recursive formula, to look up at the sequence of numbers that you have from earlier, in the first point of the outline at the top of the OEIS entry, and use those entries, but make sure you pick the right ones. You have to look at the offset, or use a known value that you know. For instance, if you know that a sub 3 is equal to 4 in this example, make sure that you look to make sure which ones is the 0, 1, 2 term. Some of them start at 0, some start at 1 occasionally, so you have to be a little careful there. But you can use the known values in the recursive formula. And I did that for n equals 3 and n equals 4 and n equals 5. I think I only gave everybody at most 8 values to plug in, 2 for each formula. In this previous version, I had one where there was 3 values to plug in. So the rubric says 9 total demonstrations, but I think there will be just typically 8 total demonstrations, maybe less, depending on your formulas, whatever it says in your email. Here's one with a product for k equals 2 to n. And I tested that out for a couple of n values, n equals 5 and 6. And then here's a generating function. So if you have a generating function and it's tested for n equals 7 or 8, you have a choice. You can either use the derivative commands in Wolfram, and then, for instance, an ordinary generating function in this case, you have to divide by the factorial. Or you can use the series command in Wolfram, and then you can just pull out the coefficient. Finally, I think I had I didn't have any exponential generating functions for this one, just an ordinary generating function.